So, as I said, this is the determinant of this cross product. Okay? Just look easily how to obtain this from the determinant theory. I think this is a high school subject, okay? And it's there. Now, the trick is as follows. You write down the first term over here. Then you do as follows. I erase here. I have to reproduce these three terms over here. So that's a trick. We call permutation. You do as follows. I have 1, 2, 3. This is, for instance, I have 1, 2, 3. If I have, for instance, 2, 1, 3, then I link this, and this. So there is one intersection. So this here is odd. Okay, this is my even. I compare. For instance, if I have 3, 2, 1. I always compare. Let's erase first here. Erase here and put the permutation here. Suppose I have 3, in this case, 2, 1. It's even or odd? Look, 3 with 3, 2 with 2, okay? And 1 is 1. See? Then you find the sign easily, okay? When I have odd or even permutation. So you can see that I will apply this here, this example, okay, just to here. See, I use the permutation 1, 2, 3. How can I use this? Okay, that's it tricky. I put 1, 2, 3, 1, 2, 3, and so on. And just look at here, plus. Look, after 2 comes 3. Then I write A3. After 3 comes 1. This is B1. Minus 3 comes 1. I have A1, B, in this case, after 2 comes 3. You see, this is E1. The next one is E2. Plus, look, you look at here, 3, after 3 comes 1. After 1 comes 2, minus. After 1 comes 2, after 3 comes 1. And 2, I have. Compare this with this, you see? So you don't need, okay, to develop the determinant. You just write the first one, just crossing, okay? The first row with the first column, write this determinant, and the rest use the permutation symbol. Now, what I want is just relate the cross product to the Levi-Civita. It's quite easy. So I will do like that. I use the definition of the permutation symbol. Then I have the component of A cross B, let be CI. See? So, CI, it's important to know exactly what I mean. See? Look. By inspection, no demonstration, I can write CI, you see, the component of this is equal epsilon I jk AJ BK. You see, don't forget that this here is C1. This over here is C2, and this over here is C3. So the vector C, I can write as CM, in this case, EM. See? These are dummy. Okay? C1, E1, plus C2, E2, plus C3, 3. Or I can write CP, EP. You see? Because a dummy. That's a vector. You see, I'm working only the component. Now, look how interesting it is. Put it here. JK. Suppose I want C1. C1 is equal, you see, C1. Look, the left-hand side is I is free. Okay? So the right-hand side must be free also. Okay? I choose 1. Okay? The x1 component of vector C. I think then I write here x1 component of C. This is equal epsilon 1. See, C1 epsilon 1. J, K, AJ, BK. Look at that. Look how simple. This I have 1. Attention there. You see, J, since it's 1, J can be 2 or 3. Yes, because J cannot be 1 because epsilon 1, 1 will be 0. It can, but I'm working with 0 term, okay? So J could be 2 or 3. If J is 2, I have epsilon 1, 2, K. If J is 3, or epsilon 1, 3, K. Now, in this case here, K must be 3. Must. Cannot be 2, cannot be 1. Must be 3. In this case here, K is equal 3. On this here, down here, K is 2. You see? Because it's 1, 3, so only, I conclude, must be 2. But this here is positive for k is equal to 3. And this one is negative. Why is negative? Because I have 1, 3, 2. This is 1. I'll write down, first of all, I write down to compare the permutation. 2, 3. This have, in this case, 1, 3, 2. So this I link here, I link here, and I link here. Look, one intersection, okay? Then this will be negative. This 1, 2, 3, 1, 2, 3 is 0 intersection. So this will be positive. So if I develop this, I'll have two terms exactly like these two terms over here. You see? One sign is plus and the other sign is minus. As soon as I get this, I forget this, and then I rotate the permutation and go there. See? That's proved. It's proven that CAB. I can represent, attention now, not C vector, is CI, which in the literature is called vector. See? If you have one free index, as component, one free index is called vector. If you have 0 free index or only